Alright, in this video, we're going to look at goal M.2.4 in the ATIT study manual, and this goal is focusing solely on geometry. If you're following along in the ATIT study manual, you will notice that there are several shapes, um, parallelograms, rhombus or rhombi, that's how you say them in plural, or rhombi. Uh, I don't quote me on this, but to my personal opinion is I don't think you need to know all those formulas by heart. There are some that you want to be familiar with, such as rectangles, circles, and triangles. And those are going to be the ones that I cover here. To play it safe, if you can memorize them all, great. But the ones that I think you really need to know are rectangles, circles, and triangles. And we're going to look at 4 examples in this video. These two here, and then this one, and this one right here. So let's go ahead and get started. We want to find the area and the perimeter of the following shapes. Something about area to go ahead and mention. Area is always going to be in square units, and I'll show you why, but I just want to go ahead and stress that to you. Typically we write that as units squared, whether it be feet squared, meters squared, yards squared. Think about it when you go buy a house, or if you want to go rent an apartment, you want to know how big it is, and typically that's the floor space, and that's always given in like square feet or something like that, right? And then perimeter, that's just given in plain old units. So units. What do I mean by that? If you want to put a fence around your yard, you don't want to know how many square feet of yard you have. You want to know the distance around your yard, so you just add up all the feet around the edge of your yard. That's what perimeter is, the distance around a shape. So given that, taking that into consideration, now finding the area, the formulas. And if we look at this crazy shape right here, these are not identical to what you see in your ATIT study manual, but they're very similar. So if we want to find the area of this thing, well, it's a weird looking shape, but notice if I cut it right here, if I cut it right there, really what we have here are 2 different shapes. We have the area of the rectangle, okay, see that? And then we have another rectangle right over here. So we want to find really the area of 2 different rectangles, and then we want to add them together. Well, it's still tricky. The area of a rectangle, there's nothing wrong with or there's nothing too crazy about that one. You probably are familiar with the area of a rectangle. We take the length and we multiply it by the width. Some people refer to this as base times height, however you want to call it. Let's look at the yellow one. So the area of the yellow rectangle, I'm just going to highlight this A in yellow, and that is not yellow, but now we do have yellow. Let's find the area of this yellow rectangle. So we're talking about a length and a width. Well, notice this yellow rectangle, we have both of those measurements given to us. So the length, it don't matter which one you call the length, as long as you call one of them the length and one of them the width. So how about 5 can be our length, 5 meters, and then our width can be 3 meters. Multiplying those 2 numbers together, we get 15, but it's not just 15, it's actually 15 square meters, or 15 meters squared. And the reason why, if you're familiar with algebra, you almost want to think about it like you're multiplying variables. M times M is M squared. That's where we get those square units from. Now that is only the area of this yellow piece. We have to come back and find the area of the green piece as well, because we have 2 pieces that make up this. Think of this as like a living room and like a hallway or something like that, and you want to put carpet in it. All right, so if you want to lay carpet, you need like square meters or square feet or whatever when you go shopping for it. Now we want to be careful with this here, and the reason why is because you may say, well, we got 7 by 1, and that is not correct. Sure, that says 7, but 7 is actually the measurement all the way across this thing. And if I'm looking at just the green, all I really want is this measurement right here for my length. If we want to call this our length and call this our width. Again, it doesn't matter which one you call which. So the length and the width. How do we find this? Well, what do we know about this measurement from here to here? What do we know about this right here? From here to here, that's 3 meters. It's the same thing as this down here. So that's 3 meters right there. Now let's take that into consideration. This is going to be 4 meters because the distance from here to here is 7, right? And then we just take 7 minus 3. It tells us what we have left over. So that's how we find the missing piece for this rectangle. So let's take our length of 4 meters times our width of 1 meter. Again, it does not matter which one you call which, and if we multiply those, we get 4 meters squared. Our total area is going to be the sum, so we have 19 square meters. Now, it goes to mention, I will not show it here, but I do challenge you to do this. You could definitely take this same exact shape that we just worked out, and you could break it up differently. You could break it up along this line right here, and you could find the area of this rectangle, and you could find the area of that rectangle. You will get the same answer, but your two regions, these two numbers here will differ, but still the sum of those will be 19 square meters. I challenge you to try that. If you have any questions, leave a comment in the comment section below. Now, let's find the perimeter of this shape as well, because we got to find both the area and the perimeter. Well, I did erase some things, but I want to keep the 4 meters up here. That's very helpful right there, because the 4 meters is the distance from here to here. It's the length of this section right there. And the reason why I want to keep using that is because the perimeter is going to be the distance around this shape. So we're talking about like the wall of this living room and this hallway. You know, what's the length of all these walls, so to speak. Now, we're still missing one more piece as well here, because we need to find the distance from here down to here as well before we can add up all these sides. Well, we can take a very similar approach to what we did a while ago with this piece. Since we know that the distance, or the length from here all the way down to here is 5, that means that the distance from here down to here also has to be 5, right? Well, what do we know about this? What's that distance right there? What's that length right there? That length is 1. So if that's 1 meter from here to here, then we got to have 4 more to give us that total of 5 right there. All I'm doing is taking the total length, 5, and I'm taking away that 1 because I don't want to factor that into this piece that I'm trying to find here. So that has to be 4 meters. Well, lucky for us, I mean, these ended up being the same numbers. And it turns out we just add up all of these sides. So the perimeter, adding them up, I'm going to start with the 5 here, and I'm going to go counterclockwise. So 5 meters plus 3 meters plus 4 meters plus another 4 meters right there. I'm just adding up the sides on the outside, and then plus this 1 meter. And then last but not least, plus the 7 meters. So if we add all these up, 5 plus 3 is 8. 8 more gives us 16. That's 17. And then that's going to be what? 24. So 24 meters right there. That's going to be the distance around this thing. Now notice I said meters. I didn't say meters squared, because we are combining like terms, so to speak. Think algebra. In the algebra class, when you combine like terms, we just add up all these coefficients, add up all these numbers that we have here, and then we write that variable down. Well, really, that's what we're doing when we find perimeter. I hope that makes sense. Now, some other things to point out in this particular example. This is going to be a little weird, but I want to explain it anyway. When you have what looks like a rectangle with like a single section missing like this off of a corner, I don't teach it this way, but if you notice this, like this distance here is going to be the same thing as that distance right there. And then this distance here, or that length there, is going to be the same as that length there. So, let's look at that red and that pink. The pink is going to be the same as that one. The red is going to be the same as that one. Now, we are making some assumptions here. We're making assumptions that all of these angles that we have in here are right angles, and we're going to make that assumption. You should pretty much just be dealing with right angles with these types of shapes on the TEAS test. Well, with that said, we can just totally bonk out this 3 right here, because we know the distance across this whole thing, don't we? The distance across this whole thing from here to here is going to be the same thing as that up there. So that's 7 meters. Just taking a different approach here. And the same thing will apply over here to this side. We can just throw away that 1 because we know the distance from here to here, the distance along that line right there, that whole line from here to here is going to be 5 meters. Well, notice if we add this up, 5 plus 7, now really I'm looking all the way around this crazy shape now. So it's going all the way around. 5 plus 7 is 12, and then we got 12 more because we got another 5 and another 7. So 12 plus 12 gives you the 24 square meters. Just a little trick right there. I wanted to mention it to you because you may hear somebody else mention that. And it's hard for me to cover every single thing you're going to run across, but just a little fun fact. All right. So that's the 2 answers for our first problem. Now the second problem here, what do we have going on in this problem? That's why I have a calculator over here, because we're going to round this thing off to find the perimeter of this thing. Now what we have here is like a rectangle, and then we have this half circle, and we can make the assumption that this is a half circle because you have one pretty similar to this in your ATIT study manual. But we're going to find the area and the perimeter of this thing. Let's start off with perimeter first this time. Why not? So perimeter is equal to, well, we got that 20, we got 8, and we got 20. But notice I stopped there. So we got 20 plus 8 plus 20. So 20 feet plus 8 feet plus 20 feet. Now, you do not count this. We don't want to cut across the shape to find the perimeter. So we do not count that dotted line. That dotted line is pointless to me, to be quite honest with you, for right now. Well, what are we going to add on? We want to add on this distance right here. Okay. And now, okay, well, what is that? That's a circle, right? Yeah, kind of, sort of, but it's a half circle. It's a half circle. And when we talk about perimeters of circles, what we really want to talk about here is the circumference of a circle. But the circumference of a circle covers the distance all the way around. So if I start right here on this dot and I go all the way around this ugly circle that I've drawn here, that would be the circumference of the circle. Well, I'm not going around a whole circle. I'm going a half circle. So what we want to find here is half the circumference. Now, this is a formula. So you got two formulas for circumference. I have a video on my channel as well that covers a lot about circles, where I discuss formulas and where the formulas come from. So I encourage you to check those out. But the two formulas for the circumference of a circle are going to be pi times d, or you can use circumference equals 2 times pi times r. D is the diameter, R is the radius. Now, assuming if you're somewhat familiar with circles, maybe you are, maybe you're not, it's okay. But if we take 2 times a radius, 2 times a radius is going to be this diameter. That's why these two formulas that you see here are the same. Now, which formula do we want to use? It doesn't really matter. Well, okay, well, what's going on? Okay, we got to have a diameter, or we got to have a radius to find the circumference. Well, to do that, this 8 feet is this length here. That length right there is also 8 feet. So from here to here, that's 8 feet. That is the diameter of that circle, the diameter of that half circle. So let's use this formula right here. But bear in mind, I said it, but we're not talking about it just yet mathematically, but we got to find half the circumference. So circumference of a circle is pi d. So circumference equals, and I'm just going to use 3.14 because your calculator does not have a pi key on it on the ATI TEAS test. So 3.14 is what we commonly use for pi, and then we multiply it by the diameter, which is that 8 feet. Well, let's just come over here to the calculator, 3.14, let's multiply by 8, and we get 25.12. So this is approximately 25.12 feet. Now, what we want to be careful here is this. Notice I said half the circumference. This would be the distance around the whole circle had we had a whole circle up here, which we don't. So what we want to do to this thing is we want to take half of it. We want to take half of it, we just divide it by 2. So we're going to take this circumference we have right here, circumference, and divide by 2. Therefore, we're taking that 25.12 feet, and we're cutting it in half, dividing it by 2. So divide by 2. That's going to take the 25.12, divide it by 2. So we get 12.56 feet. 12.56 feet. So this piece here is the missing piece that we need to add up in here into our problem. So I'm going to tag that on. So we get 12.56 feet. And now the perimeter, when we add up all these sides, let me slide some of my stuff out of the way here. So just adding it all up, they're all in feet, and we don't have to convert to anything. So 20 plus 20 plus 8, that's going to be 48. So 48 plus 12.56, that's going to be 50.56, or excuse me, not 50, but 60.56. So that's going to be the perimeter of our weird looking shape here, 60.56 feet, okay? That's the perimeter. Now let's find the area. So let me do some cleaning up here. Of course, I could erase everything, but I like to save these files for future reference. So I'm just going to, tell you what, we'll go down a little bit, and we're going to take, let's see, we should be good right there. Okay, so the area. What in the world do we have going on here with the area? The area of this shape. Well, if we break it up into two pieces, kind of like what I did over here, I broke it up into two rectangles. We can't break it up, both of these sections up into rectangles, but at least we can look at this blue piece here, which is a rectangle. And then we can also come and look at this pink section right here, which is a half a circle, which I've already mentioned, but now we don't want to talk about circumference anymore. So we want to find the area of the blue region and the area of the pink region, and very similar to what we did over here, we want to add them up. Add them up, okay? So the area of our shape. I want to get this stuff out of the way. That goes with this over here. But the area of this shape right here, we want to take the area of our rectangle. Well, the area of our rectangle is going to be 8 feet times 20 feet. Very similar to what we did back over here when we found the area of our rectangles. And this is going to be just the blue region. Okay. So we have what? 160. 8 times 20 is 160. And remember, feet times feet, we're finding area. So we have square feet. Square units, don't forget that. And now let's come and find the area of our dark pink region, which is the area of a half a circle. Well, the area of a circle is, there's only one formula that you need to know, that you need to memorize, and that is pi r squared. Pi r squared. Now, this is the area, this is the formula for the area of a whole circle. So what we want to do is we want to take pi times, now, our radius, up here I did use the diameter, because that is what that is. The radius is always going to be half the diameter. The radius is really going to be the length of the line that goes from here right to our edge. And that's half of the distance all the way across this circle right here, this half circle. So half of that's going to be 4. So our radius is going to be 4 feet, and we want to make sure we square that. But now, notice this formula, pi times radius squared, pi times radius squared. Well, what we want to go ahead and do after we figure that out is we want to go ahead and divide it by 2, because we don't have a whole circle. Remember, we don't have a whole circle. We got half a circle, so that's why I'm going to divide it by 2. So 3.14, and let's go ahead and square the 4, so 3.14 times 16. That's the area if this thing was a whole circle, roughly 50.24 square feet. Notice feet times feet, or feet squared right there. But we want to divide this by 2. So divide by 2, press enter, and we got 25.12. Ha! Ironically, this is crazy. 25.12 square feet. What did I laugh about? We're getting that number there. Do not make that assumption. That's just coincidental. Plus, we ended up dividing that by 2 anyway. Circumference and area, there's 2 different formulas. There's 2 different ways of finding them. Don't think there's ever going to be a real strong relationship like that you're always going to get the same number somehow. No, that's not the case. So with all that said, let's see here. Okay, well, what's the total area? We got to take the blue plus the dark pink. We got to add those together. So total area is going to be the sum of these two. So let's take that 25.12 and let's add the 160 to it. So that's going to be the what? 185. Yeah, so 185.12. 185.12 square feet. All right, so that's a lot. Now, I want to cover some word problems with you, because the TEAS test might not necessarily say, hey, find the area, find the perimeter. So we're going to look at 2 examples where it does not say find the perimeter or find the area. You need to know what to do. And then plus you got to read the problem a little bit more carefully. So these last 2 are going to be a little bit challenging. How many laps would John have to run around this track to go 1 mile? Round your answers to the nearest tenth of a lap. Okay, so let's just say the starting line is right here. Okay, this is the starting line, start. Okay, so he's going to run 1 lap, boom, boom, when he goes like that. When he goes back to the start, that's 1 lap. Well, what we want to figure out first is well, how long is 1 lap? How long is 1 lap? Well, that is going to be the perimeter of this shape, right? Well, good news. We got some easy parts. This straightaway here, 330 feet. This straightaway here, 330 feet. Well, what about this? Oh, here goes that half circumference again, right? We got a half circle. Oh, look over here. Here's another half circle. Hello, think about this. Now, this 210 does not correspond to the length of this curve. The 210 corresponds kind of like the way we had that, or like, the dotted line that goes across here. So this right here, the diameter, if you will be 210 feet. Well, so the distance, let's say 1 lap. 1 lap is equal to, automatically, if he starts here, he's going to have to run, eventually he's going to have to run this straight away, and then he's going to have to run this straight away. So let's just go ahead and add those up. So 330 feet plus 330 feet. But then we got to count these 2 half circles. Well, 2 half circles make a whole circle. Think about that. This half a circle is going to be half the distance. Well, this is going to be another half a distance. So really, even though we have 2 sections that make up, we got a half circle here and a half circle here, honestly, you can think about it as being a whole circle. With that said, let's use the circumference of a circle. We can either use 2 pi r or pi d. I'm going to use pi d, pi times the diameter. So therefore, pi is 3.14. Our diameter is going to be 210 feet. That's the distance all the way across this half circle here. So 210, and that's going to be feet. So 3.14 times 210. Let's see what we get there. 3.14 times 210. Now again, I'm not going to divide by 2 here. And the reason why I'm not going to divide by 2 here, if it was just one half circle, then yes, I would divide by 2. But since we have a half a circle here and a half a circle here, that makes a whole circle. So we can just use straight up the straight up formula for the circumference of a whole circle. So we want to add that on as well, plus 659.4 feet. So let's add up this measurement, and this measurement, and that's going to be the distance or the length of one lap. So one lap is equal to, take the 659.4 and we're going to add 330 plus 330. Well, really that's the same thing as adding 660. So we get 1,319.4 feet. Well, we're still not done with this problem because we have to read this question very carefully. How many laps would John have to run around this track to go 1 mile? This is in feet. You have to be careful when you read these problems. I didn't mention that yet because I was hoping maybe you saw that and you might have been thinking, hey, I wonder if he's going to mention that. Here we go. Well, this thing I wrote over here, one lap, let's set up a proportion. One lap is 1,319.4 feet, or it's approximately that, and we're going to be okay with that. All right, well, equal to, we're trying to figure out how many laps. We don't know how many laps. Well, since I have laps at the top here, I'm going to set up a proportion and say X laps over, now, what do we got to put down here? We have to put feet. Well, I mean, I don't know because I've never taken the TEAS test. I get feedback from students who take it, from the classes that I teach for the TEAS test, and they do say you got to know some of your conversions. But then on some questions, they'll give you the conversion. The conversion here is 1 mile is the same thing as 5,280 feet. Basically, if you take a ruler that's 12 inches long, take a ruler 1 foot long, if you line up 5,280 of them, that would be a mile. All right, so that's what we want to use. One lap is this many feet. X laps is going to represent 5,280 feet. That's going to be 1 mile because remember, this right here is 1 mile. So if we can figure out X, we're going to figure out how many laps it will take to go 1 mile. What we can do here is we can cross multiply and divide. That's how we solve proportions. We've seen that in a video prior to this. So cross multiplying 1 times 5,280 is just 5,280. And then we want to divide by the number that's getting multiplied by the X. That was the shortcut I gave you back when we looked at proportions. So we want to divide this by 1,319.4. So we need to go roughly, okay, it says round to the nearest tenth of a lap. Well, pretty much, if he runs 4 laps, I mean, just a hair over 4 laps. I mean, not even a fraction of a foot, really. So 4 laps is what we're looking at. So X is equal to 4 laps. And even if we need to round to the nearest tenth, as you can see, that 0 is going to tell that 0 in the 10th spot to stay the same. So 4 laps. John would have to run 4 laps around this track to go 1 mile. I hope that makes sense. And now our last problem. So we got 1 can of paint which contains 1 gallon of paint, will cover approximately 30 square meters. How many gallons of paint will be needed to paint this wall? Okay, I'll tell you what, how many cans of paint? How many cans of paint will be needed to paint this wall? Take note of the 2 identical right triangular shaped windows, which will not be painted. Round up to the nearest can. So notice I changed my little word there to can. Well, lucky for us, you have to be careful when you read it, but 1 can of paint is 1 gallon of paint. Okay? The gallons are not even really that important here because we're trying to figure out how many cans. But, you go buy a can of paint. It is, I think most of the time they come in around a gallon. I mean, you can get pint size ones and stuff like that as well. And everything's in meters. So we're trying to figure out, okay, 30 square meters. We don't have to do any conversions here. That's great. Well, we're not going to paint the windows. These are some weird shaped windows. I'm going to give you a shortcut right here in a second, and maybe you already see it, but I'm going to go ahead and talk about this. We want to take the area of the rectangle. So the area of our rectangle is going to be length times width, so 12 times 15. So 12 meters times 15 meters. All right, and then just don't forget when you're multiplying these, it's always going to be in square units. So we're looking at 180 square meters. Okay, now this would be the number of square meters if we painted the whole entire wall like that, the whole thing. Well, really, we don't want to paint these windows. So we want to kind of come back in here and we want to take that off. Well, you don't want to paint it and then go back and unpaint it, right? But really, we're not painting that. So we're not going to paint that area of the wall. Notice I said area. And we're not going to paint this area right here either, right? So really what we're going to do, if these are identical triangles, which they are, I'm going to take the area of one triangle. And I haven't mentioned the triangle formula yet, but the area of a triangle is 1/2 times the base times the height. Well, which one's the base, which one's the height? It does not matter since we have a right triangle. And I think for the most part, you're going to be dealing with right triangles on the TEAS test. If not, you will probably be given the height or the base or something like that. But here, the base, we can call that 4. So 1/2 times 4 meters, that's our base, times our height of 2 meters. So let's multiply this. 4 times 2 is 8, and then let's take half of 8. So half of 8 is 4 square meters. Now, this is the area of one triangle. Notice we have two triangles, right? That's just the area of that one. Well, this triangle is identical. So we're just going to double this area. And we don't say times 2 square meters. We just double it, multiply it by 2. So really the area of those two triangles together is going to be 8 square meters. Well, here is your shortcut, okay? If we were to take these two triangles, now we can't do this in real life, but what I'm gonna do is I'm gonna take this triangle right here and I'm just gonna drag it like that. What type of shape do we have? It's a rectangle, right? What's the area of a rectangle? Length times width, 4 times 2. So really, even though we have two separate shapes, we can think of it as being one rectangle. That's where the area of a triangle comes from. Well, that and a parallelogram, but nonetheless, look, the area of this shape now, this rectangle is gonna be 4 times 2, which is 8. Boom. It's the same exact answer. But again, we have a weird window here. So, I mean, most people probably are going to look at this and say, hey, I need to find the area of this triangle. Got it. I got two of them, so we double it. But I want to go ahead and show that shortcut to you. So what do we do here? Remember how I colored everything in a while ago? Then I took away this part and I took away that part. Well, notice I said took away. So the area to be painted. What area do we want to paint? We don't want to paint the full rectangle. So we're going to take that 180 square meters and we don't want to paint the two windows. So we're going to subtract those 8 square meters. Therefore, we're left with 172 square meters to paint. All right. So how many cans of paint do we need? Well, let's just figure this out. One way you can do it is you can just divide by 30 and you're done. And let me go ahead and show that to you. We can take this area that we want to paint, we take the 172, and we can divide by 30 because we have 172 square meters. We can divide it up into 30 square meter sections, if you will, and that's going to tell us how many cans we need. So 6 cans of paint. 5 cans of paint wouldn't cover it. Even if this was like 5.2, you would still want to round up because you can't buy 5.2 cans of paint unless you went and got, one big can of paint and you got the little pint sample sizes, which everybody does. But it just says here in this problem, round up. Regardless of our answer, we would round up. But here, clearly, we said we're going to round up to 6. So watch this. We're going to get the same answer by taking a slightly longer approach, but probably a better to understand approach using a proportion. Well, what do we know? We know that 1 can of paint covers 30 square meters. So 1 can of paint, 30 square meters, equals X cans of paint. Notice I'm putting cans. And then at the bottom, we want to figure out how many cans will cover 172 square meters. Well, if you solve this proportion, you will see that you take 1 times 172, which is 172, and then what are we going to divide by? The number getting multiplied by X. And notice I am typing in the exact same thing as what I did up here. That was a shortcut there. So what we need here is we need 6 cans of paint to paint this wall here. And again, I've given you a lot of shortcuts here. I've showed you how you can relate triangles and rectangles. Because time is going to be a factor when you're taking the TEAS test. I mean, you can't spend too much time on a problem. Now, you're not going to run across one question on the TEAS that asks you to find both the area and the perimeter. That's where the bulk of this video was taken up right here at the beginning, because we were doing a lot of stuff. I recommend checking out some more videos on my channel. There's plenty on YouTube already where you can just like type in area and perimeter of weird shapes or something like that. Go to Google. There's plenty of examples out there for you. If you have any questions, leave them in the comments section below. And there you have it. That's goal M.2.4 in the ATI TEAS study manual. And that's it for this video. I hope it helped.